I want to start out with a little bit of a warning. I am talking about cosmology, but I am not myself a cosmologist. My field in astronomy is meteorites, asteroids, small solar system bodies, things close to us. Cosmology looks at things that are far away in space and time. Though I'm not a cosmologist, I had the privilege for many years of living in community with Father Bill Steger, who sadly died of cancer a few years ago. Brilliant, brilliant man. He was a student of Sir Martin Rees at Cambridge, who was now the Astronomer Royal, and his classmate at the time that he was a student there in the 70s was another cosmologist by the name of Stephen Hawking. And they remained good friends all their lives. A lot of what I say comes from a chapter of a book that he wrote for us a few years ago, and a book that he actually wrote himself, Creation and the God of Abraham. I say that mostly to remind you that there is a depth of theology underneath what I'm saying that I can only introduce you to, I can't do justice to. And the fact that I'm brave enough to get up here and do it is because I'm reminded of a phrase that C.S. Lewis writes in his book on the Psalms, that he says, I'm a good person to write about the Psalms because I'm one chapter ahead of the rest of you. And I know what the hard stuff looks like. When you're an expert, you forget what's the hard stuff. I'm actually going to start with a quote from Stephen Hawking. It's a book he wrote a few years ago. Because there is such a law as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist. It's not necessary to invoke God to light the blue touch paper and set the universe going. It's from a book he published with Leonard Nalabo a few years ago called The Grand Design. It's a very bold statement. It's, designed to grab your attention, the kind of thing you'd put in the blurb on the back of the book. The argument behind it, that we can explain the origin of the universe without having to invoke God, follows a theme that's very popular with these people who call themselves the New Atheists. They're interesting, they're mostly British, they're mostly elderly white males. I've got nothing against elderly white males. I intend to be one someday. But while they call themselves the New Atheists, there's not actually a whole lot new about it. And Stephen Hawking's hardly the first person to declare that God's obsolete. And it's really easy to mock the theological naivete. As I say, most of them are British, and the British are infamous for not allowing their science students to take Philosophy 101. So it shows. The two cultures of C.P. Snow came from there. But there is a certain specious glibness to Hawking's argument, because what if he hadn't been able to come up with a theory that could start the universe, invoking just gravity? Would that have then made him a believer? I hope not. I suspect not. I contrast the medieval view of the universe with the view of the universe that modern people think is the medieval view of the universe. In fact, that's not the medieval view. And Stephen Hawking's ideas about the theology and the meaning of creating something from nothing, or why is there something instead of nothing, are equally fallacious. Because I'm going to say something about Stephen Hawking's argument that he doesn't need God to start the universe. Something, if he's going to be outrageous, why can't I be outrageous? He's right. You don't need to invoke God to start the universe off. In fact, you shouldn't invoke God to start the universe off. To appreciate where I'm coming from for saying this, and why, and at least in part, they're on the right track, and why we as Catholics should listen to them, I'm going to do a little bit of an excursion into the physics that Hawking and his collaborators are talking about. Don't need to follow the mathematics, but you need to know sort of the kinds of arguments. And I'll also return to what's all the things that are wrong with this picture, supposedly, of the medieval universe. Okay, the cosmology that Hawking and his collaborators are working on is based on the theory of relativity by Albert Einstein, which was, more than 100 years ago. The first part of the theory, called special relativity, was published in 1905. It looks at systems that are moving at a constant speed, constant direction, uniform motion. It's a special case, hence special relativity. In this theory, Einstein shows how a lot of the things that we take for granted as common sense really don't work, especially the relationship between mass and space and time. And what you measure, if you and I are measuring exactly the same phenomenon at the same time, there's no such thing as the same time, but from different frames of reference, we would measure different speeds, different masses, if one of us is moving relative to the other. It gets to be very confusing. But this theory of special relativity is able to explain a whole lot of things that we had observed and couldn't understand before. Most famously, it gave us the equation E equals mc squared, which is how you can turn mass into energy. It's the source of energy that allows stars to shine and bombs to bomb. It also explains how the magnetic field is just a relativistic expression of electricity. Special relativity is mathematically elegant, and it works. General relativity came along about 10 years later. In this theory, Einstein develops his ideas for the more general case of a universe where there are things accelerating and there are forces. And in particular, he tried to come up with a new theory, a new way of describing gravity. Now, gravity, even then and today, remains the most difficult of natural forces to understand. Isaac Newton, you can tell my science fiction background, Isaac Newton gave us the full idea of gravity in his theories, but he never attempted to describe what gravity actually was. It was just enough to be able to describe with mathematics how it behaves. He came up with the equations that allowed you to predict, for example, how long it takes for an apple to fall from a tree, or how long it takes for the moon to go around the earth. But why it works that way, that's a question he never even tried to answer. When he was challenged on that, challenged to explain how gravity works, he just said, "I feign no hypotheses." Actually, he said it in Latin. It sounds much more elegant there. By contrast, ancient cosmology started with the observation that anyone can see. You walk outside, you look across the field, and you can see the world is flat. We're living on a flat world, and when it's clear, you can see there's a dome of skies overhead. This is the view that's described in Genesis. But it's not Genesis saying you must believe this is what the world is. Genesis is saying everybody knows this is the best science of its day in the year 500 BC. They didn't say 500 BC, but you know what I mean. And given that this is the best, understanding of what the universe is like, then Genesis talks about the God who made it. But in Genesis, it describes a dome amidst the waters, separating the waters above and the land below. And you notice that, there's water and hail coming through little ports in that dome, and there's water underneath, and we've all lived there. This is the universe, the common sense observational universe that we all live in. But it didn't take a whole lot of observation to recognize that it was incomplete. A few hundred years later, by the year 300, the ancient Greeks understood well. Everybody in Greece knew that the world was round. You can see it for yourself just by looking at the round shadow of the Earth as it falls on the moon during a lunar eclipse. And you can see then that instead of having a dome, what you've got is a round world that's surrounded by shells. And as you move around the shells, going from north to south, some stars will fall away to the north and other stars will appear in the south, which is exactly what you see. And then, looking at the stars, you notice 7 wandering stars, 7 stars that don't fit in with the others. They're all moving in the same set of constellations, the zodiac, all named for animals. It's a zoo. And the 7 constellations are the sun, the moon, and the 5 naked eye planets, Mars, Mercury, Venus, Jupiter, Saturn. Each one was assumed to have its own shell, one inside the other, inside the other, inside the other. And they were so fundamental, the fact of these 7 objects, that their names are the names we give to the days of the week. If any of you speak Spanish, you recognize that immediately. In Italian, likewise, in French, likewise. Even in English, we've got Saturn Day and Sunday and Moon Day. And the other days in English are just the names for the Norse versions of the same god. So you've got Tyr's Day and Woden's Day and Thor's Day and Freya's Day. But the planets don't move in a constant motion. They seem sometimes to move backwards and forwards, and sometimes faster and sometimes slower. So in the year 370, more or less, the Greek philosopher Eudoxus comes up with this idea that each sphere containing a planet is embedded in another transparent sphere that you don't see, that might be rotating on a different axis. And if you have enough of these spheres, you can account for the odd motions of the planets backwards and forwards. By AD 150, the Roman astronomer Ptolemy came up with a simpler way of calculating it, where you have circles and then each planet moving in a circle around the Earth. The circle could be a little bit off-center, or what they called eccentric, would also have a circular motion as it moved along that circle, and maybe another circular motion on top of that circular motion. If you have an infinite number of circular motions, you can match perfectly any motion of the planets. With this system, he was able to calculate and reproduce the actual motions of the planets. So, you've got a theory, the theory matches the data, therefore it proves the theory is true, right? That's a fallacy that a lot of people still cling to when they try to understand science. Now, that system is totally different from the flat plane with the dome and the water and above and below that you find in the gospel. St. Augustine noticed this. A few people noticed this. St. Augustine wrote this fabulous book called On the Literal Interpretation of Genesis. And if you know anybody who thinks that they're interpreting Genesis literally, send them a copy of this book. You can find it for free on the internet. His idea of a literal interpretation is completely different from what we would think of as literal. It was more literary, I guess would be a way of describing it. But in particular, he warns there, and I'm going to quote him, even a non-Christian knows something about the earth, the heavens, and the other elements of the world, about the motion and orbit of stars, and even their size and relative positions, about the predictable eclipses of the sun and the moon, the cycles of the year, the seasons. This knowledge he holds to as being certain from reason and experience. Now, says St. Augustine, it is a disgraceful and dangerous thing for an infidel to hear a Christian, presumably giving the meaning of Holy Scripture, talking nonsense about these topics. Something that Augustine is warning us about 1,600 years ago. There is, of course, a certain irony, because the things that we know of as being certain from experience and reason is the Ptolemaic system that we now know is nonsense, which is a lesson right there about wanting to base your theology on the best science of the day, because the best science of the day is going to be obsolete in another day. But what I find interesting is that there is this big shift from the flat earth that's described in Genesis 1 to the intersecting spheres. There is no Galileo crisis. This is a much, much bigger shift of cosmologies than you ever saw from Galileo, which was, merely moving the origin point from the earth to the sun. There is no crisis. A common feature of all of these cosmologies is that people happily adapted them to the theology and the metaphysics that they also believed in. Now, the Aristotelian physics that went hand in hand with this cosmology said there are 4 elements that each have their natural place. Rock, natural place, center of the earth. Water, natural place above the rock. Rock falls through water. But below, air and fire, because air and fire goes up. Air bubbles through water, but fire goes up even through air. So there's these 4 realms. Things want to find their natural spot. So if you drop a rock, it falls down. If you have bubbles in water, they go up. But any motion backwards and forwards represents life. Winds move. The word for wind, anima, is also the word for animal, is also the word for spirit. Trees are moving back and forth because there's, little creatures living inside the trees called dryads. Did I get that? Dryads and nereids and all those. I can't keep track of which is which. The spheres themselves are populated by gods, spirits, or in the medieval view, ranks of angels. And they're given names. First of all, let me go back to this picture here. The Earth in this picture is not the center of the universe. I just want to remind you of that. It's the bottom of the universe. Imagine you're looking at the Roman Colosseum. The gladiators are at the center. The emperor is up at the farthest rank, watching everything. The most important parts are the outskirts. The Earth, if you want to say that the medieval view had the Earth as the center of the universe, and that's why they were mad at Galileo, well, what's in the center of the Earth? The inferno, the devil. That would make the devil even more important than people. I don't think that's what they were saying. The Earth is at the bottom of the universe. It's the bottom of the chain of creation. And all the other spheres have ranks of different angels. And they're given names. Angels, archangels, thrones, dominions. You recognize those names? We're going to come across them again. It's important to remember that this view of the universe with the ranks of angels surrounding the Lord, this geocentric view of the universe, where the Earth is at the center and the sun and the planets are going around it, is not just moving the center point, the way that happened between Copernicus and the people before Copernicus. Because it's not like they have the moon with its craters. They didn't know the moon had craters. Or Saturn with its rings. They didn't know that Saturn had rings. It's not just a picture of how things are moving, but it's also a picture of what things are. It's assumed that the saints in the biblical firmament are the outer spheres of the universe, and then you've got the other spheres that are moved by angels in perfect, eternal, circular motion. And these spheres talk to each other by sending demons back and forth. And each sphere had its own talent, and if you happen to be born when the demon or genius of music happened to be overhead, a little bit of that genius got splashed into you. And if you didn't, tough luck. There are different. There's one of the geniuses who was apparently the genius of sleep. I thought, yeah. Now I know where I was born. When Galileo comes along and suggests that the Earth is, following Copernicus, the Earth is not the center but going around the sun, it upsets 1,500 years worth of theology, but it also challenges the astronomers. Because if the Earth was moving, you would expect to see the stars appear to move as the Earth moves. Tycho Brahe looked very carefully. He could see the positions of the stars, and to his precision, he saw no such motion. So he came up with a system where the Earth is still at the center, the sun goes around the Earth, all the other planets go around the sun. Mathematically, this is identical to the Copernican system until you get to the stars on the outside, but it solves the problem of why you don't see the stars appear to move relative to the parallax of the stars relative to the Earth. What's more, this system fit in with the prevailing physics of the time. Most people, even at the time of Copernicus and for the next 100 years, the time of Galileo in the next 100 years, did not believe in the Copernican system because the observations they could do at that time didn't match the predictions of a Copernican system. You had to have stars immensely far away, farther than they thought was possible. There were people who really did like the Copernican system. One of them was Johannes Kepler, But Kepler, who basically took over Tycho Brahe's data set, was also powered by this concept that the physical universe was a mirror of the metaphysical universe. If you look carefully at the Copernicus book, 1542 Copernicus book, which apparently nobody actually read. It's actually been called the book that nobody read. Though Owen Gingrich, who wrote the book called The Book That Nobody Read, shows a lot of people did. But I don't know, have you ever seen Scientific American? And you see an article in Scientific American. They tell you when you're going to write an article for Scientific American, make sure you have a good title, a good first paragraph, and good figure captions, because that's basically all anyone's ever going to read. And the same was true with Copernicus's book, because everybody read the figure and they saw the Earth and or the sun and all these circles around the sun. That's actually not the Copernican system. The Copernican system still had those little circles within circles within circles. It just had one fewer of them by having the sun at the center. And even the sun was not exactly at the center, but it had to go a little circle around the actual center in order for its position to match the observations. And Kepler hated this idea that the sun was making a little dance around nothing, because trying to match physics and metaphysics, Kepler said, what's the most glorious thing in our solar system, or the most glorious thing in the universe? The sun. What's the most glorious thing in our metaphysics? God the Father. Therefore, the Son is God the Father. And God the Father can't be moving this little crazy dance around nothing. The light coming off the sun was the Holy Spirit. Well, in order to make sure that the sun stayed in one place, he came up with the idea of elliptical orbits. Not because it was more elegant mathematically, but because his metaphysics demanded that the sun doesn't move. Now, it's also worth noting that Kepler's theology, his metaphysics, was considered absolutely bonkers by everybody, even in his own day. Of course, that never stopped a physicist who's smarter than everyone else, or at least thinks he is, or she. But it did serve to inspire this breakthrough. And that's an interesting thing to point out just in the history of science. As I say, the Tycho Brahe system matched the data as well as the Copernican system. With an infinite number of epicycles, the Ptolemaic system matches the data as well as the Copernican system. So why was the Copernican system considered better? It's not because it matched the data. It's not because it was particularly easier. It actually wasn't. But it inspired people to ask new questions and develop new ideas about how things worked. In particular, how gravity worked. Because it inspired and matched the data, the data matched the theory of Isaac Newton. Once Isaac Newton had laws that could explain the motions of the planets, then science took a big step further. But it could only explain the motions of the planets if you assume that there were planets that had motions that needed to be explained. Ptolemy was around for 1,500 years, and it was a sterile theory. The Copernicus theory, within 200 years, had launched a revolution in physics. Still, it's important to remember that this medieval system was not easily overthrown because it was the basis of our literature. It was the basis of Dante. It's the basis of Chaucer. It's the basis of how we understood how God and his universe worked. And it worked by assuming that here on Earth, things are corrupt. I move a rock and it stops. In heaven, things are not corrupt. I move a planet and it keeps moving forever. Obviously, that's the cause of original. It was caused by original sin, and original sin corrupted everything below the earth, the moon. That was the metaphysics. There are two physicses. It was such an elaborate theory that it was assumed by everybody in the Western world who was educated, and it was built into the literature and the songs that even the uneducated would know about. C.S. Lewis, you remember C.S. Lewis, he had a day job. He was a professor of Renaissance and medieval literature, and he wrote a series of lectures late in his life, which I think is maybe one of his most marvelous books, called The Discarded Image. And he so loved it, he wound up writing, "Few constructions of the imagination seem to me to combine splendor, sobriety, and coherence in the same degree. Only had one problem. It's not true. But when it was overthrown, there was no unifying system that you could use to explain and organize music and literature and art, proportion, mathematics, astronomy. Instead, we've got Newton's laws where the same laws occur everywhere, both in space and on Earth. And if things don't, move forever on Earth, it's because there's this force called friction. But without friction, Newton's first law says, if you don't do anything, it'll keep doing the same thing forever. Any change that occurs because there is a force. Newton's second law, I can explain that force. It's the proportion of how much mass it's got and how much acceleration it's got. And if I'm doing a force on it, it's doing a force on me. Those are Newton's three laws. If the same laws apply everywhere, there's no difference between the heavens and the earth. The old cosmology doesn't hold. It has to be replaced with a new cosmology. And in this new cosmology, there's no longer a privileged place or a condemned place. Every place is the same as every other place. It's no longer spirits that are causing, no longer angels that are causing, no longer the love of God that is causing the planets to move. The old line, "Love makes the world go round," is not a modern song line. It was a principle of physics in the Middle Ages. The force that explains the motions of the planets is the same force that explains the fall of an apple. And even though he can't explain what gravity is, at least he can describe how it behaves. Now, if you've got a mechanical universe like this, it's tempting to say, well, I don't need angels anymore to move things, so you didn't believe in angels in the Middle Ages? I can show you what they're doing up in the sky. Now I don't need angels to explain what's going on up in the sky. I've got a mechanical universe. Newton did have an interesting problem. He said, if the gravity of the sun is what moves the planets around, how come the gravity of the planets don't disturb each other? And his only answer was, well, I can't explain it, so God must take care of it. And the fact that the planets are stable proves that there's a God. There's also the big question, even if Newton's laws can explain everything that happens in terms of forces, you have to ask, where did the planets come from? Where did the star come from? Where do the forces come from? Where at least was there a prime mover? And so it's very tempting to then identify God as the prime mover that Plato had talked about that starts all motion. Nothing in Newton's physics argues against that idea of a God. He didn't try to answer, where do things come from? He only attempts to ask, why do things work the way they do? But what comes out of his physics is the idea that once you've got the universe set in motion, the laws inexorably describe its future course. Okay, I can accept there's a creator God, but once there's a creator God, he sets the universe off and then, sits back and looks. That's not the personal God who would intervene in nature unless it's to violate his own laws of nature. And this led to the Enlightenment theology of deism. To the deists, God's a clockmaker. He designs the clock, he assembles the gears of the universe, he winds them up, sets them going, and then doesn't do anything more except keep his eye on the time once in a while and reset things when planets get out of line. Actually, it turns out, along with physics, Newton came up with differential calculus. And it took about 100 years for people to really appreciate calculus, but one of those who did was a French mathematician, Pierre-Simon Laplace, who went back to the question of the motions of planets, came up with a wonderfully fabulous, detailed mathematical description of the motions, and realized you didn't need God to fix things. The story goes, Laplace is describing these calculations to Napoleon, and Napoleon says, well, where's the role of God in this book? And Laplace says, I have no need for that hypothesis. Well, in a sense, he's right. He didn't need that hypothesis. Incidentally, the story of Newton, of Laplace and Napoleon comes from a book published in 1872, almost 100 years later, called A Budget of Paradoxes, which this is a well-known anecdote in Paris, but there's no other documentation, and a lot of the other things in this book really aren't quite right. But there is a certain irony. In the 200 years since he did that, we've worked out much more detailed the motions of planets, and their mutual motions in the early solar system lead to a chaotic rearrangement of the planets. So where Laplace was able to prove to his satisfaction that the planets were stable, in fact, we now know that at least at one time in the past they weren't. Which is why you don't want to base your theology on the best science of the day. And even though Laplace had much better equations to describe gravity, he still didn't know why there was gravity in the first place. There's another problem with Newton's laws. Laws of physics depend on knowing all the forces that act on a body, like the force of gravity, and every force that acts on that body, and the exact position of that body, and the exact velocity of that body, and then you can calculate its exact future. All of that relative to an inertial frame of reference. All of that assuming three very strange things: mass and space, or position and time. Now, you probably don't think that time is a particularly strange thing unless you think about what actually is time. You probably don't think that space is a particular odd thing until you actually wonder, well, what actually is space? And mass, if you think mass is obvious, try teaching freshmen in physics. Because the more you look at it, the more you go, wait a minute, it's the amount of stuff. Well, what's stuff? Well, that's the amount of mass. Wait a minute. It's the weight of, no, because things have different weights on different planets, but the same amount of stuff, the same amount of mass. Well, is it volume? No, because you can have a box of air and a box of lead bricks in the same volume, but they've got different amounts of stuff. What is that stuff? Well, we call it mass. What is mass? I don't know. To paraphrase John von Neumann, who was a mathematician at MIT, you never really understand physics, you just get used to it. What's more, it's a really hard struggle to understand Newtonian physics. I remember as a freshman, I was actually a sophomore at MIT, I transferred in. I went to MIT to read science fiction stories. And I'm taking this class, and I don't understand it, and it doesn't make any sense, and it doesn't make any sense, and it doesn't make any sense. And one day, in a fit of frustration, I just do the problem this way, because at least I'll get the right answer. And the TA, the teaching assistant, goes, yeah, that's how you do it. And I go, really? Oh, it makes sense. And my friend, for whom it doesn't make sense, says, oh, how does it make sense? And I try to use the words that didn't make any sense to me the day before, and now did make sense, and I can't describe it. You just have to get used to it. You just have to live with it. But once you do get used to it and live with it, it seems so obvious that you can't understand why anybody could not understand Newtonian physics. And if you've ever talked to an engineer who thinks everybody else is stupid, you'll know why. But things aren't as easy as they seem. Coil of hose. This is a classic issue in teaching science. Here's a coil of hose. It's hooked up to the water. if I turn on the water, and the water goes around and around and around and around and around, and it comes out the end, what's the path of the water after it comes out the end? And for anyone who has not taken Newtonian physics, the answer usually is, well, it's been trained to go around and around in the circle, so it'll keep going around and around. Those of you who have taken Newtonian physics know that the water, I don't care how many times it goes around, when it comes out the spout, will go in a straight line. Those of you who have actually used garden hoses know when you turn on the water, it goes flying all over the place. Now, it is possible to try to explain every wild gyration of that hose in terms of Newtonian physics, just as it's possible to explain the motions of planets using, Ptolemy's epicycles. It's not clear that it's a particularly easy way of doing things. Newtonian physics, even where it applies, assumes a universe that is much more simple and much more understandable than the real universe actually is. And that's even before you get to the issues of moving near the speed of light or working in very, very small spaces like quantum physics. Everything that you measure in Newtonian physics is against the inertial frame, and nobody's been able to actually define what the inertial frame is, because there is no inertial frame. And that's one of the things that led to relativity. So when Einstein comes along with special relativity saying, you know what? Everything that you thought you got used to with mass doesn't work because the mass that he's measuring moving at 1/10 of the speed of light is different from the mass that she's measuring moving at 9/10 of the speed of light when you're measuring the same mass of the same object. How can the same object have more than one mass? Well, it's also got clocks that appear to move at different rates compared to your clocks. Well, it's also got dimensions that appear to shrink depending on how fast you're moving against its motion. What appears to be a measure of mass and time and distance in one frame of reference can look really different in the different frame of reference, and both of you think you're in the so-called inertial frame of reference, and there's no way to choose between them. We won't even talk about quantum physics. And Einstein's general theory makes this even worse, because he says that what we're calling mass is actually a warping of space and time. What do you mean? Well, if things want to move in a straight line, but the space that they're moving in is warped, it will look like its motion is bent. You see the bright stars there. They're actually not stars, they're galaxies of 100 billion stars. You see the rings of light? Those occur because behind that galaxy is another galaxy whose light going from straight it to us is blocked by the forward galaxy, but whose light coming off at an angle gets bent back into our telescopes uniformly as a ring around that massive galaxy. These Einstein rings are seen all over the place. The first time this was noticed was by a fellow named Arthur Eddington, who went to an eclipse. He knew where the stars were. When the sun was next to one of those stars, you can't see the star because the sun's there, unless there's an eclipse blunking out the sun, and then you can measure where the star is, and he noticed that its position looked different from where it was supposed to be because its light had been bent. This was reported in a press conference in 1919. Incidentally, think of this. General theory of relativity by Einstein, proposed at the university in Berlin during World War I by a German, proved within a year after World War I by an Englishman, even though they were on opposite sides of the war. That was a little controversial in itself. The only person from the United States who attended the press conference was a reporter from the New York Times who happened to be in London covering a golf tournament. He was a sports reporter, and he reported the science of this press release as if it was a sporting event. So you can see it in the tone there. Men of science more or less agog over the results. The theory not just is correct, but it triumphs. Stars aren't where they seem to be, but nobody need worry. A book for 12 wise men, no more in all the world could comprehend it. Total nonsense. Einstein never said that. But I remember as a kid hearing that only 12 people in the world could understand Einstein's theory of relativity. By golly, I was going to be the 13th. I'm not. One of the results was that by the time Einstein came to give a bunch of talks in academic circles in America, he was treated as a conquering hero, and to this day, having wild white hair and a German accent is our stereotype of the physical genius. Well, it's interesting that the guy on the left there is actually Arthur Eddington. The guy with the familiar-looking collar on the right I'll get to. You see, if mass warps space and time, then the mass of the universe should be warping the space and the time of the universe so as to pull all of the universe into itself. Look at it another way. If everything's got gravity, what's holding things up from each other? We know the moon doesn't hit the Earth because it's moving around the Earth. We know the stars don't fall into the center of the galaxy because they're moving around the center of the galaxy. We knew that our cluster, our galaxy, doesn't fall into the other galaxies because they're all moving around a common center of mass. But there is no one point in the universe that all of the clusters of galaxies are moving around. They look for it. It's not there. What's more, the idea of cosmology is that there's no privileged place, which would be a privileged place if there was a spot that everything in the universe went around. So what stops the universe from falling in on itself? Especially if you've got an infinite amount of time, sooner or later it should have happened. Well, in 1920, there was a Russian physicist, Alexander Friedman, suggested, well, maybe it's because there is an inherent expansion going on in the universe, just out of nowhere. It was a couple of years later, though, that this Belgian, Georges Lemaitre, who has 2 degrees, a doctorate in mathematics from Louvain and a doctorate in astrophysics from MIT, he organizes this into a coherent cosmology that notices if the universe is expanding now, which I'm hypothesizing, then it must have been smaller together in the past. The energy in the universe would be in a smaller volume, which is the same, the energy density we call temperature. So it'd be more energy in a smaller space, it would be hotter. And there should be a point where you have an infinite state, which quantum physics could explain as an infinite quantum state, out of which the entire universe expanded. And that it's not just things expanding out into space, but because space warps with mass, it is space itself which is unwarping into the universe that we see as it expands. If that's true, then there's going to be a point in time that you can calculate by seeing how fast are the galaxy clusters, how fast is the expansion going on now, and work backwards, when was it all in one spot? There would be a time zero with this very high point of energy, what he called a primeval atom. Einstein heard about this and said, it's elegant mathematics, but that can't possibly be true. There was an Englishman who wanted to be one of the new atheists, but he was a generation too soon, named Fred Hoyle. Hated priests, hated religion, hated the idea that the universe in the past would be different from the universe today, tried to come up with an alternate theory that would allow the expansion, which of course Edwin Hubble then saw a couple of years after Lemaitre predicted it. One of the reasons we suspect that Hoyle was so adamant against this theory was that the guy who invented it was, as you can tell from the collar, a Catholic priest. He was not a Jesuit, by the way. He hated being called a Jesuit. He is living proof that you can be smart and not be a Jesuit. rare as that might be. Well, Hoyle gets on the radio in England about 1949, gives a series of talks about modern astronomy, and in passing references his beautiful continuous creation theory that has a universe expanding with this Father Lemaitre's Big Bang theory. And he makes up the name Big Bang to make fun of the theory. One of the differences, one of the things you would look for, if the universe actually has a finite age rather than has just always been creating, is that stars from a long time ago would look different from stars made in the present day. Early stars might only have pure hydrogen. Older stars would be made out of the materials formed inside the early stars, so you'd have different populations of stars. There was a big meeting held, sponsored by the Vatican Observatory in 1957, on stellar populations, because these populations of stars were actually observed. And the people who didn't like the Big Bang were desperately trying to figure out a way of explaining them away. At this meeting, Fred Hoyle and Georges Lemaitre finally meet. They became best of friends. They shared a ride back north. They spent a couple of weeks in Switzerland on vacation, Fred Hoyle and his wife and Father Lemaitre, and remained great friends for the rest of their lives, because science is not a big book of facts. Science is a conversation. It's a conversation about the facts. And as this conversation develops, you've got to have people who are interested in the same questions as you, but who have different opinions. Otherwise, you'd have nothing to talk about. They needed each other. They needed each other to push each other. And eventually, enough of the evidence built up that Fred Hoyle had to admit that Lemaitre was right, because he was a good scientist. And Lemaitre respected him because he was able to come up with an alternate theory. In fact, about this time, Pope Pius XII, who pictured himself something of an amateur astronomer, speaks to the Pontifical Academy of Sciences saying, "Isn't it interesting that the astronomers are talking about a beginning to the universe?" Those of us who have read Genesis will recognize that. And Father Lemaitre got an audience with the Pope and said to him, "Please, Your Holiness, don't say that. It's just a scientific theory. 1,000 years from now, who knows if we'll even be asking the same question." So we've worked out this idea of a primordial atom, a beginning point, a spot that looks like the creation described in Genesis. You noticed that the point where all of the universe is in one point is so hot and dense that it could be considered an enormous amount of energy. And Genesis starts out with, "Let there be light." Oh my God, just coincidence? I think not. About once a week, I get an email from somebody who thinks they've discovered this for the first time and is attempting to build an entire theology on recognizing that Genesis must be true because it says, God says, "Let there be light," and we now know that the universe started with a burst of energy. Making the other days of the Genesis fit is a little more of a challenge, just to mention that. More to the point, there's another and a more fundamental problem. Thank you. A more fundamental problem than just the idea that maybe the physics is incomplete and 1,000 years from now we'll have different physics. And the problem is brought up really by Stephen Hawking. Where did that primeval atom come from? Showing that the universe starts from a primeval atom, does that demonstrate the necessity of a creator God? Well, Stephen Hawking's been working on this topic for a long time. And he's looking into the possibility that even when there is nothing, you just have a vacuum, the vacuum itself has a non-zero what they call zero-point energy. And because of quantum theory, it will fluctuate. It's never exactly the same thing from instant to instant. And if you wait long enough, it's conceivable that by chance you could have a quantum fluctuation of the primordial vacuum energy, which is essentially gravity, produce a singularity in space-time that then explodes into what we call the Big Bang. Apparently, he uses something called imaginary time, conceiving that there are no three-dimensional spatial boundaries to the universe. I don't know what that means either. I'm just reading what Bill Steger was telling me. Anyway, he and his colleagues have postulated a universe like the one we inhabit could have been produced spontaneously from a random fluctuation of the cosmic gravity wave function. And Hawking is as good as anybody in this field, so when he says it's possible, I'm not going to argue with him. There's no reason to suppose he's got it wrong. Maybe he's got it wrong, maybe he doesn't, but I'm not going to argue that. So it doesn't mean that you don't need God to start the universe. Let's remember what Newton's idea of God was. Newton was a deist. He thought God was not personally involved in the lives of individual beings. He was the prime mover, and that was it. His physics worked for a long time, seemed to be testable, seemed to be something that you could build your cosmology on, both the physical cosmology and the metaphysical. No split between science and religion. God said, let Newton be, and all was light. God could be demonstrated to exist because he was needed to fill in the gaps that Newton still had in understanding how the universe worked. But if you use God to fill the gaps, the God of the gaps, the most obvious danger is that, as what happened with Laplace, once the gaps are filled by something else, you don't need God anymore. And your so-called proof that God exists is turned on its head, and instead of proving the necessity of God, you wind up proving that there's no need for God. The Jesuit theologian Michael Buckley wrote a book on the origins of modern atheism, and his argument is exactly that this is what led to atheism among the Enlightenment. So, the last gap we had to fill was the origin of the universe, the prime mover, the blue touch paper that sets things off. And now it looks like Hawking thinks he's closed that gap, and so he says it's the final death knell of God, and he's right. The God that Laplace and Hawking are overthrowing is a God who's merely one force alongside the other forces of nature. You got the force of electricity, you've got the force of gravity, and you got the force of God. And one of those things made the universe start. If that's all that God is, then God's not supernatural. God's not outside space and time. God doesn't exist before the beginning. What you've got is just another pagan nature deity. Might just as well be Zeus starting the universe. Furthermore, that kind of God, the modern version of the watchmaker God, isn't the personal God of Scripture. But then, when you thought the universe was just a big machine, you had no room for a personal God. Frankly, you had no room for beauty or love or any of those things that can't be described with equations, or free will. And if that's the universe you've got, it's a universe that doesn't have any meaning. And you know, the modern physicists are not the first ones to come up with this. We have, of course, the Nobel Prize cosmologist Steven Weinberg, who writes at the end of his book on the creation of the universe, the more the universe seems comprehensible, the more it seems pointless. And before him, you've got Bertrand Russell, who speaks of building a philosophy on the firm foundation of unyielding despair. Which didn't stop Bertrand Russell from having a pretty happy life, but never mind that. Rabbi Sachs, in the United Kingdom, points out that this is not a new idea. You recognize vanity of vanities, all is vanity? He says Better translation is this: meaningless, meaningless, says the teacher. Utterly meaningless, everything is meaningless. Man's fate is like that of the animals. The same fate awaits them both. As one dies, so dies the other. All have the same breath. Man has no advantage over the animal. Everything is meaningless. Book of Ecclesiastes. It's not something that comes out of modern physics. It was around more than 2,000 years ago. Such a view is completely self-consistent and philosophically naive. The whole genius of the God of Abraham, Sachs tells us, is that God is supernatural. What he calls the discovery of God beyond the universe. The gods of paganism, the lightning gods, they're all inside the universe. They maybe were stronger than human beings, longer lived than human beings, but they are still pieces of the universe. They could not have created the universe. They can't give meaning to the universe. Wittgenstein says, the sense of the world must lie outside the world. Everybody in this room is sitting on a chair. That chair has meaning because you're sitting on it. You who are not part of the chair. The meaning of the chair can only exist if there's something outside the chair that gives it meaning. The universe can only have meaning if there's something outside the universe to give it meaning. It's essential that we recognize the God it is that we're trying to find. The God of revelation. It's a God of beauty, joy, love, the way, the truth, the life. These are attributes that you cannot weigh or measure scientifically. This is a God who cannot be weighed and measured, but only experienced. Only a supernatural God can give our life meaning. Only a supernatural God, which exists outside the mechanism of Newton's universe, can account for our experience of beauty and freedom and love. Only such a God can make a universe that we study not because it, gives us better Teflon. Why do we do science? Is it going to make you rich? Astronomy doesn't, astronomy may have made Neil deGrasse Tyson rich, but nobody else. Is it going to make you powerful? Trust me, no. Is it going to get you girls? Didn't work for me. Why do we do astronomy? Ultimately because of the joy that we as human beings feel. And that joy is, I would say, one evidence of the presence of God. And only such a supernatural God would be worthy of our adoration. A God who just set off the Big Bang, even if there were such an entity, is not by that act any more worthy to be worshipped than I would worship the force of gravity. Hey, Hawking says, my idea of God is the God who started the Big Bang. But now I know that what started the Big Bang was gravity. Therefore, there is no God. That's not what the logic doesn't work. If that was his logic, then he'd say, God is the thing that started the Big Bang. Gravity is the thing that started the Big Bang. Therefore, God is gravity. Maybe he thinks that's why Catholics celebrate Mass. I can see who of you have studied physics and who hasn't. Okay. That was my big bad joke. You can all leave now. And of course, we all know that the trouble with any physics, going back to the other point that Lemaitre was making, is that spontaneous universe may look as foolish as spontaneous generation does. Because science does develop, because science does grow and change, and that's the sign of a healthy science. Our contemporary cosmology is what permeates our 21st century common sense of the universe. And yet even the physicists here among us, though we may teach general relativity, we're still thinking Newtonian physics. That's still the common sense that we're living with. We haven't completed the revolutionary shift into a system where we can treat quantum theory or general relativity with the same common sense that an engineer treats Newtonian physics. Why? Because Newtonian physics is still useful. It still, allows us to build bridges and airplanes. Even though we know it's not exactly true, it's only an approximation. Maybe there'll be a time in some future century which only the vestiges of our cultural assumptions remain, the same way that we still keep the days of the week even though we don't believe in those gods anymore. Maybe future students will have forgotten what we mean by space and time and mass, but still believe that if you're going to be a brilliant physicist, you have to have wild hair and a German accent. Maybe the one philosophical implication to take from all of this is the realization that humanity's common sense understanding of how the universe behaves is always going to be a woefully incomplete picture of the physical universe. As each new advance in cosmology gives us new questions, we also have a new appreciation of the complexity and the beauty of the universe. I'll tell a little story here. There's a reporter in a British newspaper called The Independent who writes a column on gardening. A very, very good writer named Emma Townsend. And I read some of her stuff, and I read about her, and actually read this one article that was online, which she wrote about 10 years ago, describing her childhood in England. And as a little girl, she had a loving father. She thought Daddy was wonderful. She really, really, and just with a very close relationship, as you hope that fathers and daughters will have. And, you know, in her eyes, Daddy was the most wonderful person in the world, you know, a real rock star. When she got to be about 10 or 11 years old, she gradually learned that her father, Pete Townsend, really was a rock star. Lead guitarist for The Who, you know, just, you know, millions of records sold. I'm told that that Sean Lennon came home from seeing Yellow Submarine and said to his dad, you know, John, why didn't you tell me you were in a band called the Beatles? We are in that same situation when it comes to God. We have grown up with God as our Father, Abba, Daddy, this personal God. The more we learn about the universe, the more we are stunned that the same God that we've been calling Daddy actually created, beyond what we can imagine. It's a wonderful, wonderful feeling. It's interesting to see how religions adapt as our different cosmologies shift. That's where we find out what's essential and what's dated, you know, the cosmology of Genesis 1 is completely dated, but the message of Genesis 1, that God deliberately made the universe, it wasn't an accident like the Babylonians said, that God loved the universe, that God did it in an orderly way, that message about God is truer than it ever was, even though the cosmology that's used to illustrate it is, you know, a little out of date. Our cosmologies change, but the questions we ask remain. Who are we? Where do we come from? What are we doing here? One of those questions was first posed by Newton's contemporary Gottfried Leibniz in an essay called On the Ultimate Origin of Things. Why is there something instead of nothing? Hawking says, I can explain it as a quantum gravity. No. Hawking can't explain why there are laws of physics, why there is space and time, why there is a vacuum to fluctuate. Why is there something instead of nothing is very different from how did things get started. The idea of the universe created from nothing actually is tossed out almost as an aside in the second book of Maccabees. Mother is seeing her sons being tortured and trying to give them courage by saying, remember, look to the heaven and the earth and see everything that's in them and recognize that God did not make them out of things that existed. That's the Creator God. That's the philosophical premise of our metaphysics, which was not invented by a great prophet, but by a mom, and which is the point that stays constant even as our explanation of how things developed may change. What Hawking's referring to isn't that kind of creation. It's just creation from something that already exists. In the theology of the God of Abraham, the Creator gives the physical processes of the universe the power to be what they are. The Creator isn't the same thing as those physical processes. Creatio ex nihilo is not an answer to the question of how things got started. It's instead the answer to the ultimate question of why reality itself exists, with all of its dimensions of space and time, and all of its rules for how those dimensions behave. And so Hawking does us a favor by saying that we don't need the God who's throwing the lightning bolt. He's actually teaching us good Catholic theology. When you were in ancient Rome, you didn't need science. If you wanted to know why the lightning bolt hit, it's because the god of lightning bolts made it. If you want to know why the volcano went off, it's because of the monster under the mountain. And you could explain everything in terms of nature gods. It's only when Christianity became almost atheistic, by eliminating all of those gods in favor of the one supernatural God, only then was it possible to do science. The only difference between Stephen Hawking and me is I only believe in one more God than he does. And I believe in such a God not because I've come to that God at the end of some logical chain of calculations. For one thing, I've seen my calculations. I wouldn't trust them that well. I believe in God, but not because I don't have any other explanation for the origin of the universe. I believe in God because of the person of Jesus Christ in history, in Scripture, in my own prayer, in my own life. I believe because I've experienced what physics shows me but cannot explain: beauty and freedom and reason and love. A universe that exists, it's inexplicable. A universe that follows rational laws, wholly unexpected. A universe whose laws can produce beauty. One whose rational laws not only produce beauty, but are themselves beautiful. I adore God, not just believe in him, but adore him. Not just because he's made a universe, but because he's made a universe that's so much fun to play in. And that's what science is.